Hi, hello, welcome to homeschool. This is your class 10 mathematics. Yeah, chapter number 8 real numbers is not there for the syllabus, and chapter number 9 polynomials is also not there. Coming to your chapter number 10 quadratic equations. Quadratic equation, immediately you can remember its degree is 2, means its highest power is 2, then we call that equation as a quadratic equation. The general or a standard form of a quadratic equation is ax square plus bx plus c equal to 0, and a cannot be equal to 0. Why? What happens? Quadratic equation means its highest power should be 2 or degree is 2, then we call that equation as a quadratic equation. Suppose if a becomes 0, then this value becomes 0. Then it will be a linear equation. Bx plus c equal to 0 will be left, and that becomes a linear equation. So for a quadratic equation, a cannot be equal to 0. Okay, where a is a coefficient of x square and b is a coefficient of x and c is a constant term. Okay, most of the questions they may ask write the standard form of quadratic equation. Ax square plus bx is equal to 0, where a cannot be equal to 0. Next, solving the quadratic equation. Solving the quadratic equation, we can go with three methods. One is by factorization method and another is by completing square method. If we use completing square method for this quadratic equation standard form, we get quadratic formula. Quadratic equation, when we simplify by using completing square method, we get this quadratic formula. Okay, another method is quadratic formula. Quadratic formula is also called as Sridharacharya's formula. What is that? Quadratic formula is also well known as Sridharacharya's formula. This is very important formula to solve the quadratic equations. That is x is equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. We know solving a quadratic equation till now by only factorization method. Sometimes some equations we won't get the roots by factorization method. Those type of equations we get the answers in formula method. This here completing square method is deleted. We can expect most of the multiple choice questions regarding the solving equation. Okay, or they may ask you formula. Observe here carefully, minus b plus or minus root of b square minus 4ac by 2a. And one more thing you need to remember, what are the two roots of quadratic equation? What are the two roots of quadratic equation? This is a quadratic equation. If we solve the equation, we get two roots. What are the two roots? The two roots are minus b plus root of b square minus 4ac by 2a or minus b minus root of b square minus 4ac by 2a. You can write this as x is equal to. So these two are the two roots of the equation. So at a time we have written with plus or minus. Okay. What are the two roots of quadratic equation means? You need to write these two. What is the formula for quadratic equation? You need to write this one. Okay, now coming to next point is discriminant. Discriminant is represented by either capital D or a delta. That is discriminant value D is equal to b square minus 4ac. So before solving the equation, we can say the nature of roots. How will be the roots if we simplify that equation? How? Let us see the three cases here. Nature of roots of quadratic equation. If discriminant is equal to 0, there are two real roots and equal roots. Two real and equal roots will be there. If we solve, we said there are two roots, but here with plus sign and here with minus sign. Means these two are distinct. But if discriminant is equal to 0, then they will be having two real and equal roots. Okay, if discriminant is greater than 0 means what? Suppose it might be 1, 2, 3, 10, 15, anyone. Suppose if the discriminant value is that means greater than 0, then what will be the roots? There are two real and distinct roots. There are no equal roots, they will be distinct, means they are not equal or they are different roots. Okay, suppose if discriminant is less than 0 means -1, -2, -5, -50, negative sign if it is followed, then that value is less than 0. D is less than 0, then there are no real roots. There won't be any roots for that equation. Okay, is this clear? Suppose for the quadratic equation, if the discriminant is 0, there will be two real and equal roots. If discriminant is greater than 0, then there will be two roots which are distinct, real and distinct. And suppose if discriminant is less than 0, there are no real roots. Is this clear? So regarding these only your multiple choice questions will be there. Okay, so coming to next chapter, chapter number 11, Introduction to Trigonometry. Trigonometry, it is one of the branch of mathematics, deals with the study of ratios and angles of a right triangle. Trigonometry is applicable only for right angled triangles. In this, we are going to learn about 6 ratios first, and then table, then complementary angles and some identities. Let us see here. Let me take a right angled triangle ABC, right angled at B. If this is a right angled triangle, then the other two angles will be acute angles. Acute means less than 90. Okay, so this is 90 and these two angles will be less than 90 degrees. This is acute and this is acute. Now, very important point you need to understand is, in your question it might be, what is sin C or sin A, cos B, cos A or secant C? They may ask you some questions. Or instead of that, I just try to say with angle theta. Okay, suppose if the angle is here, look here carefully, this is theta symbol. Okay, theta angle is here. You may say it as a C or a theta also. You can say, no problem. Observe the right angle triangle. If this is right angle, what is this side called as? Opposite side is hypotenuse. Okay, that is fixed. There is no change with that side. Okay, now these two sides we should understand carefully. Suppose if your angle theta is here, then its side, what is this side? It is opposite to this angle. Okay, so let me write this as opposite. And what about this side? Adjacent. It is touching side. So I may say it as adjacent side. Okay, understand first right angle triangle, then these all will be easy. Right angle triangle, opposite side is hypotenuse, and if I take angle here, this side becomes opposite and this side becomes adjacent. And we can write all the ratios. Same manner, suppose if your angle is here, look here carefully, suppose if your angle is here, can I say this opposite? No. For this angle, which is opposite side? This is opposite and this will be adjacent. Okay, like this they will be interchanging, but hypotenuse won't change. Okay, is this clear? So any angle you can take. Okay, let me take for this angle theta only. Okay, sin theta. We should know the 6 ratios perfectly. Sin theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. Easy to remember, children. Sin theta. Oh, you can remember. opposite by hypotenuse. Cos theta, you remember. And tan theta, OA, you remember. Opposite by adjacent. So observe here carefully. Opposite O, hypotenuse H, adjacent A, you remember shortcut. Sin theta, O means opposite by hypotenuse. If you want, you can write here O. You remember in this manner. Opposite by adjacent. Okay. Sin theta opposite by hypotenuse. Cos theta adjacent by hypotenuse. Tan theta opposite by adjacent. Next coming to cosecant theta. How to remember this? Just reciprocal of sin theta. I may say cosecant theta as 1 by sin theta or hypotenuse by opposite. Reverse children. Reverse of sin theta is cosecant theta. Same manner, reverse of cos theta. Secant theta is equal to 1 by cos theta. That will be hypotenuse by adjacent. Okay. Next coming to cot theta. Same reciprocal of tan theta. Cot theta is equal to 1 by tan theta. You can write it as adjacent by opposite. Okay, these are all very, very important, children. Now again, let's see here. Sin theta, O. Cos theta, A. Tan theta, OA, you just remember. If you're able to remember these three, just reciprocal is those. Okay. Sin theta, opposite by hypotenuse. Cos theta, adjacent by hypotenuse. Tan theta, opposite by adjacent. Coming to cosecant theta, hypotenuse by opposite. Secant theta, hypotenuse by adjacent. Cot theta, adjacent by opposite. So try to remember these all ratios carefully, children. Sin theta, opposite by hypotenuse. Cos theta, adjacent by hypotenuse. Tan theta, opposite by adjacent. Cosecant theta, hypotenuse by opposite. Secant theta, hypotenuse by adjacent. Cot theta, adjacent by opposite. Now same manner for this right triangle, I am going to give the value 3, 4, 5. Okay. So if any value is missing, you can apply Pythagoras theorem and find the missing side. After finding missing side, now find what is sin theta. Sin theta, what do you know? This is hypotenuse and the angle opposite side is opposite and the angle touching side is adjacent. No need of writing always opposite, adjacent and hypotenuse. You just try to remember. Sin theta, what it is? Opposite by hypotenuse, 3 by 5. Cos theta, 4 by 5. Tan theta, opposite by adjacent, 3 by 4. Okay. Next, cosecant theta. I said cosecant theta is always reverse of sine. What do you got? 3 by 5. Just 5 by 3 you can directly write here, children. Or just look here, hypotenuse by opposite, 5 by 3. Secant theta, hypotenuse by adjacent, 5 by 4. Cot theta, adjacent by opposite, 4 by 3. Okay, observe here, 3 by 5 reciprocal is 5 by 3, 4 by 5 reciprocal is 5 by 4, 3 by 4 reciprocal is 4 by 3. Understand the 6 ratios carefully. Okay. Now, some of the angles regarding the ratios we are going to learn by using the trigonometric ratio table. What are the angles here? 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. This is also very simple table, children. There is no need of by hearting. Okay. Most of the problems will be based on these ratios or this table. Okay. Only one line you need to remember, that is, look here, 0, 1. Next 3 numbers if you are able to remember, full table is yours. Let's see how it is. 0, 1. Middle it will be half, no? I will write here. 0, 1 by 2 and then 1 by root 2, root 3 by 2, 1. And one more thing, if you want to remember in this manner also, you can remember. Let us write 0, 1, 2, 3, 4. You can remember the first line carefully, or you may remember the 0, 1, 2, 3, 4. Divide by 4. 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4, and square root of it, what it will be? 0 by 4 will be 0. Square root of 0 will be 0. And root 1 by 4. Split the root. Root 1 is 1. Root 4 value is 2. Okay. And next this one. Root 2 by 4 I can cancel here. 2 ones, 2 twos. 1 by 2. Root of 1 by 2. Split the root. Root 1 value is 1. And root 2 I cannot split. Root 2 I cannot simplify. So as it is I will write. Then coming to next one, split the root, root 3 and root 4 value is 2. And now same manner, 4 ones are 4, root 1 value is 1. This is the way you get your first line. Okay, if you want to remember directly 0, 1 by 2, 1 by root 2, root 3 by 2, 1, you can remember. Or 0 to 4, divide by 4, square root, you get the first line. Cos theta, just write in reverse order. 1, root 3 by 2, 1 by root 2, 1 by 2, 0. Now, before knowing this, I need to say one more word here. Tan theta, opposite by adjacent. How we said? Tan theta is also written as sin theta by cos theta, children. Observe here carefully. Opposite by hypotenuse, adjacent by hypotenuse. If you divide, hypotenuse cancel, opposite by adjacent. Okay. Tan theta we can remember it as sin theta by cos theta. And cot theta you can remember as cos theta by sin theta. By using this, we can complete that table. Tan theta is what? Sin theta by cos theta. Divide sin theta by cos theta, 0 by 1. It will be 0. And if you divide these two, 1 by 2 by root 3 by 2, 2 will be cancelled. You are left with 1 by root 3. Okay. Then what about tan 45 here? 1 by root 2 by 1 by root 2, root 2 cancel, 1 is left. Then coming to tan 60 degree. What is tan 60 degree here? Root 3 by 2 by 1 by 2, 2 cancel, root 3. Then coming to tan 90 degrees. What is theta value there? Tan 90. Tan 90 value 1 by 0. I cannot define it. So this one I can say it as non-defined, not defined or infinity you can write. In order to find cosecant theta, you just divide this all with 1. Okay. 1 by 0. 1 by 0 is not defined. Then 1 by 1 by 2, it is 2. And here 1 by root 2 will be root 2. 1 by root 3 by 2, just write the reciprocal and write 2 by root 3. Then last 1 by 1 it will be 1. Then for secant theta, just write the reverse order of cosecant theta. Right now 1, 2 by root 3, root 2, 2, not defined. Okay. Then coming to cot theta, reverse order of tan theta. That is not defined, root 3, 1, 1 by root 3, 0. Okay. So like this, you need to remember trigonometric ratio table for some angles. So this table is very important, children. Secant 30 degree, 2 by root 3. Cot 45, 1. Cot 90, 0. Like this, any value, you should be able to remember all this. If you don't remember also, no problem. You can use this technique and remember the first line. And if you know sin theta, reverse order is cos theta. And divide sin theta and cos theta, you get tan theta. And cosecant theta is 1 by sin theta. Do the reverse order secant theta. Tan theta reverse order is cot theta. Like this, you should remember the trigonometric ratio table. Then coming to complementary angles. Complementary angles is very simple, children. Some of the angles is 90 degrees. Then coming to trigonometry complementary angles, sine, cos, cos, sine, tan, cot, tan, cosecant, secant, secant, cosecant, you need to remember. Okay, sine 90 degree minus theta, cos theta, cos 90 degree minus theta, sine theta. And now cosecant 90 degree minus theta, secant theta, secant 90 degree minus theta, cosecant theta. And now tan 90 minus theta is cot theta, cot 90 minus theta is tan theta. These are all very simple to remember. Then coming to last three identities you have, you can arrange these three identities in 6 other ways and you can apply in the problems. Okay. First identity, sine square theta plus cos square theta is equal to 1. Suppose if I ask you what is sine square theta, what you do? You send the other terms other side. That means sine square theta is equal to 1 minus cos square theta. Same manner, if I ask you cos square theta, you can say 1 minus sine square theta. By using only one identity, you can rewrite these two. Same manner, secant square theta is equal to 1 plus tan square theta. You can rewrite this as tan square theta is equal to secant square theta minus 1, or you can rewrite that as secant square theta minus tan square theta is equal to 1. Okay, coming to your last identity, cosecant square theta is equal to 1 plus cot square theta. Rewrite this as cot square theta is equal to cosecant square theta minus 1, or cosecant square theta minus cot square theta is equal to 1. Any way you can apply in the problem, children. These identities we apply in 4 marks problems. But as for now, we are having only multiple choice questions. If you remember these all, you can answer any type of question in trigonometry. Next chapter, chapter number 12, some applications of trigonometry. This chapter deals with only verbal problems, and in this chapter you need to observe 3 points. What are those 3 points? Line of sight, angle of elevation and angle of depression. Look here, you can see 2 right angled triangles. Let me talk about first one. Line of sight, with what you are seeing, with your eyesight, what the object you are seeing, and the line so formed is called as line of sight. Okay, so you are observing something from here. Suppose you are observing some kite or any other. Okay, your observation through your eye to the object is called as a line of sight. The arrow mark, it indicates you are observing from here to here. And here you can see a plane, that we call it as a horizontal level. And this line I can say it as a horizontal line or horizontal level, you can say. Now observe here, the angle created, the angle so formed through the horizontal level and the line of sight, this angle is called angle of elevation. Angle of elevation. Simply you can say angle of elevation looking up. Okay, angle of elevation is the angle formed between line of sight and horizontal level. Okay, this is called as angle of elevation. Angle of elevation. And now suppose a kite is so and so height and it is at a so and so distance you are standing and you are observing the kite and angle so and so given. So which ratio you are going to find? If you know, if your angle is here, opposite and this is adjacent. Opposite adjacent, you know, you can take any ratio. Either tan you can use or cot theta you can use. Tan theta opposite by adjacent, cot theta adjacent by opposite. Suppose if you know hypotenuse, line of sight distance you know, and height of the kite you know. That means if the angle is here, then this is opposite and this is hypotenuse. Opposite and hypotenuse means which ratio? Sine ratio. At the time you need to take sine theta or cosecant theta also you can take. So observe carefully what is given in your right triangle and take the proper ratio. And observe there it is elevation or depression. Angle of elevation looking up you can say. Okay. Now coming to next point, angle of depression. What is angle of depression? Same manner, the angle created by horizontal line and line of sight. But here what happens? Angle of elevation is above the horizontal level. Angle of elevation is above the horizontal level. But now line of sight is here. Horizontal level won't be there, but we need to draw a dotted line. And this horizontal line you can see. From here the angle I am going to consider. This is called as angle of depression. Angle of depression. And what is a tiny difference? The angle of elevation is above the horizontal level. Angle of depression is below the horizontal level. This is horizontal level. And now you are on the top of a building. You are observing something on the ground. Okay. So from here you are observing. That means looking down. Looking down is depression. Looking up is elevation. Okay. One more time. The angle formed between line of sight and horizontal line is called as angle of depression. And this angle is so formed below the horizontal line. That is angle of depression. Above the horizontal level angle is angle of elevation. And one more thing, wherever you see depression angles, that depression angle is nothing but this horizontal line is parallel to the ground line. If these two are parallel, then this is a transversal. Therefore, this angle is equal to this alternate angle. Depression angle again you can rewrite in the form of elevation angle. This depression angle you can equate to this angle, and now this angle will become elevation angle. Okay, angle of elevation and depression is very important, and whereas in a right triangle what the ratio is given, and according to that you need to take the ratio. This applications is mainly used to find the heights and distances. Chapter number 13, statistics. In this statistics, we are going to deal with grouped data and ungrouped data. Collection, interpretation and analyzing of a data is called as statistics. And in this statistics, we are going to deal with grouped and ungrouped data. First, we are going to see the formula for ungrouped data. Mean, median, mode. From your earlier classes, you have learned mean. What is mean? Sum of the scores by number of the scores. Yes, sum of all scores. Suppose some numbers given 1, 3, 7, 8 like this given. Sum up all these. How many scores you have? 4. Add all this by 4 will give you the mean. Median, it is the middlemost score in an orderly arrangement of numbers. Let me take one example here. 1, 5, 3, 2, 6, 1, 5, 3, 2. I have taken some 5 numbers here. Find the median for the scores. There are 5 scores. First, arrange the scores in an order. 1, 2, 3, 5, 6. Okay, either it may be ascending or descending. First, arrange the order, and now middlemost score, this is called as the median. Suppose if the scores are odd, you can pick the middle one. Then what about if the scores are even? If the scores are even like this, 1, 2, 3, 4 numbers are there. If your scores are even, what you need to do? You need to add the middle 2 scores by 2 you do. That is your median. Look here, middle 2 scores are 3 and 7. Add, divide by 2. 3 plus 7 will be 10. 10 by 2 will be 5. 5 is the median for this. Okay. Like this, if the scores are odd, directly middle one you can say. If the scores are even, add the middle 2 scores, divide by 2, you get the median. Coming to mode. Mode is the most repeated number in the given set of scores. Next, coming to grouped data. These are all ungrouped data. If your data is ungrouped, you can find mean, median, mode in that manner. Suppose your data is a grouped data. For grouped data, we are going to see the formulae. Class mark. Class mark is equal to lower limit plus upper limit by 2. Then coming to class size is represented by small h. Upper limit minus lower limit, or you can say high score minus low score. Mean. Actually, in the statistics, we have two more methods, assumed method, step deviation method. Those two methods are not there. Only direct method there for this year examination. So, only one formula I am going to say for you. That is mean by direct method. That is mean x bar is equal to summation fi xi by summation fi. F frequency and x is a score. Median is equal to L plus n by 2 minus Cf by f into h. Now we are going to know what are all this. L. Before finding median, we need to find the median class in the table. In that median class, the lower limit is called as L. N is the total frequency by 2. Cumulative frequency in median class, above the cumulative frequency of a median class is Cf. This Cf is which is just above the median class of cumulative frequency. F frequency in the median class, H is a class size. Next, coming to mode. Mode is equal to L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. In this also, we need to find first model class. How we are going to find model class? Highest frequency will check and make a round in that table. L is a lower limit in the model class. F1 is a frequency in the model class. F0 is a frequency which is above the model class. And whereas F2 is a frequency below model class. H is the class size. And one more formula you have, relation between mean, median, mode. That is 3 median is equal to mode plus 2 mean. If you remember all this, you can answer any type of question in statistics. 14th chapter probability, which is not there, and coming to your 15th chapter surface areas and volumes. This chapter is very important for formulae. Formulae plays a major role for this chapter. So you can see some solids I have written here. For all the solids, curved surface area, total surface area and volume are very important. If you know this formulae carefully, you can solve any type of question. Okay, let's see the first solid, it is cube. So cube and cuboid, I cannot say curved surface area. For cube and cuboid, I say it as lateral surface area. For cube and cuboid only, I say lateral surface area. Why? These are all plane, right? So I call them as lateral surface areas. Coming to lateral surface area, what is the formula? When I talk about lateral surface area, which surface area I am talking? See here, this is a cube, children. It is a three-dimensional figure where all sides are equal. Okay, so when I talk about lateral surface area, I am not talking about top and bottom. I am not talking about top and bottom. So observe here, this is the lateral surface area you need to say. All sides are equal, right? You can see a square, 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 square. What is the area of a square? A square. And here A square, A square, A square. Suppose if I take side as L, then what is the area of this square? L square, L square, L square, L square. How many sides are there here? 4 sides. Okay, 4 faces area. If you add, what you are going to get? That is your lateral surface area. 4 times L square, if you add, what you are going to get? 4 L square units. And coming to total surface area, these 4 faces plus top face and bottom face will give you total surface area. So 4L square plus L square is 5L square, plus L square is 6L square. 6L square. Coming to volume. Volume, easy to remember children. Area of a base into height. What is area of a base? L square. Into height is L. L square into L is L cube. Volume is always in cubic units. Let's see once again. What is the latent surface area of a cube? 4L square. Total surface area 6L square. Volume L cube. Next solid. Coming to your next solid is cuboid. This is a cuboid. You can see here 2 square faces and 4 rectangular faces. And I say this as lateral surface area only. Now, what is the LSA of a cuboid? So, for this cuboid, if you add area of a rectangle plus area of a square plus area of a square will give you lateral surface area of a cuboid. That is 2 into L plus B into H, or you may say 2H into L plus B square units. Now, same manner, if you talk about total surface area. Total surface area means this LSA plus top face and bottom face. That is very easy to remember. 2 into LB plus BH plus HL square units. Volume always remember as area of a base into height. See here, area of a base, which shape it is? Rectangle. Okay. This is length, breadth. Length into breadth into height. That means volume of a cuboid is LBH cubic units. So once again, what is LSA of a cuboid? 2 into L plus B into H, or 2H into L plus B. Total surface area of a cuboid 2 into LB plus BH plus HL square units. Volume LBH cubic units. You can see the next solid. What is this solid? It is a right circular cylinder. Right circular cylinder. Look here properly. This is a curved surface area. This is not lateral. Okay, observe here carefully. This is curved surface area. When I talk about remaining, I say it as curved surface area. Then what is curved surface area of a cylinder? How can I find this? For this right circular cylinder, see here the surface is curved shape. So I say it as a curved surface area. I am not considering top and bottom. What is CSA of a right circular cylinder? CSA means what you can see? Height you can see. And only top round. Round is nothing but circumference of a circle. What is circumference of a circle? 2 pi r. 2 pi r into h will give you the curved surface area of a cylinder. That is 2 pi RH is the CSA of a cylinder. Coming to total surface area. CSA of a cylinder plus top and bottom. What is top? Which shape it is? Circular shape. And bottom also circular shape. Then what is the area? Area of a circle is pi r square. Pi r square plus pi r square will be 2 pi r square. Now, in order to get total surface area, curved surface area plus top and bottom. So, what is the formula here? Curved surface area 2 pi RH, right? I take H inside plus top and bottom pi r square plus pi r square will be 2 pi r square. I have taken 2 pi r common. What will be inside? R. Therefore, total surface area of a right circular cylinder is 2 pi r into r plus h square units. Coming to volume. What is volume? What is volume of a right circular cylinder? Observe here. What is the area of a base? Base is which shape? Circular shape. Area of a circle? Pi r square. Height h. So, pi r square into h, that is pi r square h cubic units is the volume of a cylinder. It's very easy to remember. What is the curved surface area of a cylinder? 2 pi r h. See here 2 pi r h, how I am getting? Only circumference. Okay. 2 pi r h is the curved surface area. Coming to total surface area, 2 pi r into h plus r or r plus h you can say. Volume, pi r square into h cubic units. Coming to your next solid is cone, right circular cone. Why it is right circular cone? See here, from middle, you can see here, this is the center of a circle, this is radius and this is a height. Then what is this? We call it as slant height. Slant height is represented by the letter L. What is curved surface area of a cone? You can remember it as pi r L. Pi r L. Okay. What is CSA of a cone? Pi r L square units. Coming to total surface area. CSA is pi r L. Then total means base also will come, right? Pi r L plus area of a circle pi r square. Pi r L plus pi r square. If you take out common, L plus R you are going to get. Okay, that is your total surface area. Pi r into r plus L or L plus R. Anything is fine. Coming to volume. Always remember children, cone volume is always 1/3 volume of a cylinder. Therefore, volume of a cone is 1/3 the volume of a cylinder. 1/3 pi r square h cubic units. Coming to your next solid is sphere. Sphere. What is a curved surface area? Curved surface area, always you can remember 4 times the area of a circle. Area of a circle is pi r square. 4 times 4 pi r square. Then coming to total surface area, do it have anything extra? No. So therefore, either for CSA or TSA, same formula I can take. Okay. Then what about volume? Volume, you should remember, it is 4/3 pi r cube cubic units. Next solid is hemisphere. When you do half of a sphere, you get a hemisphere. Okay, can you see hemisphere here? Right? Now, what is a curved surface area? Only curved surface area. You have seen now sphere. What is sphere surface area? 4 pi r square. Half of it is 2 pi r square. Okay? Curved surface area of a sphere is 4 pi r square. Half of the sphere surface area is hemisphere. So, half of this means 2 pi r square is hemisphere curved surface area. Now, coming to total surface area. Total surface area, look here. CSA of a hemisphere plus you can see some shape. What it is? Circular shape. Area of a circle plus CSA of a hemisphere. That is 2 pi r square plus pi r square. It will be 3 pi r square. Okay. And coming to volume. Volume. Half of a sphere volume will be hemisphere volume. Half of it. That means 2/3 pi r cube. Only for sphere and hemisphere you will get r cube. Okay, try to remember this. These are all very easy children and they are all very interesting. See the next solid, frustum of a cone. Let me draw the figure. You can imagine easily with a bucket. Okay, this is a slant height L. Radius, big radius I am giving it with the capital R, small radius R, and this is height. Now, why we call it as a frustum of a cone? When a cone is cross section, you get a frustum of a cone. Okay, some part of the cone is removed. The shape so formed is called as a frustum of a cone. Then coming to this, what is a curved surface area? You can directly remember this formula, pi L into R plus R. L is a slant height, small radius and big radius. And coming to total surface area. What is total surface area? Curved surface area plus area of top circle, area of bottom circle. So look here. CSA of a frustum of a cone, pi L into R plus R plus area of a top circle pi small r square, area of bottom circle pi capital R square. In these two, what is common? Pi, if you take out common, small r square plus capital R square. Looks lengthy, but it is very easy. Pi L into R plus pi into R square plus capital R square. So what is your total surface area of frustum of a cone? Pi L into R plus pi into R square plus capital R square. Coming to volume. This is 1 by 3 pi h into R square plus R into capital R plus capital R square. This is the formula which you need to remember. 1 by 3 pi h into R square plus small r into capital R plus R square. Here you need two more formulas extra to remember. Suppose if you don't know the slant height, how can you find? There is a formula. L is equal to square root of h square plus capital R minus small r whole square. If you apply this formula, you are going to get the slant height. Similarly, in cone also, suppose if you don't know slant height and this is the height and this is the radius, then at that time you can remember one more formula. L is equal to square root of h square plus r square. L is equal to square root of h square plus r square. And one more, area of ring you need to find, children. What is this area of a ring? Suppose you have a circle like this. You have a big circle. In that, this circle is removed. Then so formed, this is called as a ring. And what is this ring formula? How can you get this formula? So only shaded area you need. Then at that time, area of big circle minus area of small circle. That means this radius is small r and this radius will be capital R. Area of big circle means pi capital R square minus small r square will give you the area of a ring. Okay, these are all the formulas of surface areas and volumes. These are very important, children, and most of the children will be confusing at some places. That is, suppose a combination of a solids. Okay, look here what you can see. Hemisphere and cylinder. Find the curved surface area of this if they ask you. What you need to find? Curved surface area of a cylinder plus curved surface area of a hemisphere. Total surface area if they ask you, don't split the formulas separately. What is TSA of a cylinder, TSA of a hemisphere, adding those two, don't do in that method. Observe the solid carefully. CSA means only CSA of a cylinder and CSA of a hemisphere there. Total, other than these, what is left? Top circle. So area of this circle, if you add for this, you are going to get full total surface area of the solid. Okay. Suppose a cone is placed on it. Now what is the total surface area of the solid? Observe here carefully. CSA of a, only total I am saying. Total surface area what you can see outside. CSA of a cylinder plus CSA of a hemisphere plus CSA of a cone. That's it. Don't go for anything extra. Okay. So this much only you find, that is only the total surface area. Suppose if your solid is like this. Okay. Cone is surmounted on a hemisphere. What is the total surface area? Total surface area means CSA of a cone plus CSA of a hemisphere will give you total surface area of this solid. Okay. Coming to volume, children. Suppose if they ask you what is the volume of this solid. Volume of a hemisphere plus volume of a cylinder plus volume of a cone. Okay, don't be confused. Understand the solids carefully. Try to imagine this in your mind. These solids, if you are able to imagine, you can frame any type of the formula. Okay, I hope all the chapters, all the important formulae were covered for you. So let us start in our next session with your multiple choice questions from each and every chapter. Until that, keep watching. Thank you all.